So today we are going to look at the area and perimeter of composite figures. So what is a composite figure? Well, that's what we're going to find out. Our learning target is how we can find out the area and perimeter of composite figures. So if we look at this funny looking shape right here, this is a composite figure. We don't really have a formula for this figure, but we see that there's different shapes this figure is made up of that we could find the formula of. So a composite figure is a closed figure made up of two or more shapes. So if we look at this figure here, we see that we have a rectangle, we have another rectangle, and we have a triangle. Well, we know how to find the area of those shapes individually, so together we can find the area of the whole thing. So let's find the area of shape 1. Well, we know to find the area of a rectangle, we do length times width. So here we're going to do 10 times 5 to get the area of 50 centimeters squared. Then we want to find the area of this small rectangle. Well, we know that this side of the big rectangle is 2. This side is the same because you see this little congruent mark. That means they're the same. So we know two sides are 2. We want to find this side. So if we know we have 5 for the total and 2 for each side, that means this side must be 1 because 5 minus 2 and 2 is 1. So we know that to find the area of 2, we have 1 and 3. So 1 times 3 gives us the area of 3 centimeters squared. Next we have our triangle. Well, our triangle, we know we need to find 1/2 base times height. So if we look at the base, well, the base, we have 2 and 2, and then we have this 1, so it's the same as our 5 up top. So we know the base is 5, and then we need to know the height. Well, if we know the whole height is 17, and we know that the height of the rectangle is 10 and the height of this rectangle is 3, then we have to take away 13 from 17, which leaves us with a height of 4. So now we can say, all right, well, 1/2 times 20 gives us 10 centimeters squared. So to find the area of all three together, we want to add them all up, and we say 50 plus 10 is 60, plus 3, we get 63 centimeters squared for the area. Well, to find the perimeter, all we want to do is look at the outside of the shape. So we know we have a side of 10 and another side of 10. So we have 2 sides of 10. We have a side of 5. We have 1, 2, 3, 4 sides of 2. We have 1, 2 sides of 3. And we have 1, 2 sides of 4.5. So when we add those all together, we get that the perimeter of this figure is 48 centimeters. All right, so now I want you to try to do number 2 just like we did number 1. I want you to identify the different shapes, find the area of each, and find the perimeter. So pause this video now. When you are done, play it so that we can go over it. All right, so you should have solved your problem, and now let's go over it. There are a couple ways you could have split this figure up. Maybe you said you had a triangle, another triangle, and a rectangle. Or maybe you said that you had 2 parallelograms. Or maybe you said that you have a triangle and then you have a rectangle, and then you have another rectangle, and you have to subtract out the area of this triangle. Any one of those could have worked. We will go based off of the, why don't we do our two parallelograms and see what we get here. So we know that to find the area of a parallelogram, we need the base times the height. So the base of this figure we see is 6. And the height of this we see is 2.5. So we have 6 times 2.5 will give us 15. Now because we have 2 of them, we know we can just multiply 15 by 2 to get the area of 30. So we know that this is 30 meters squared. Well, what if you did the triangles? So let's erase this and look at the triangles. Let's change my color. So what if we said we have a triangle here, and then we have 2 other triangles here? Okay, so if we find the area of 1, we know we need 1/2 base times the height. So 1/2, the base here we know is 5. And the height, well, if we know this is 6 and the whole thing is 7.5, the height must be 1.5. So we have 1/2 times 5 times 1.5, and we get that the area is 3.75 centimeters, not centimeters, meters squared. And then we have our rectangle, which is length times width. So we have 4.5 times, and the reason why we say 4.5 is because we're going from here to here, times this, which is 5. So 4.5 times 5 is going to give us an area of 22.5 meters squared. Now the third one we have is going to be this triangle. Now you notice that these triangles have the same measure, so they will have the exact same area. So we know that the height is 2.5, and the base, well, if we know this is 4.5 and the whole thing is 6, then this must be 1.5, because 6 minus 4.5 is 1.5. So we're going to have 1/2 times 2.5 for the height times 1.5 for the base. When we multiply that through, we will get 2.5 times 1.5 divided by 2. We get that the area is 1.875 meters squared. Now because we have 2 of them, we want to multiply this by 2, and we will get that the area for both this triangle and this triangle is 5.6. Oops, sorry, I multiplied that by 3. 1.875 times 2 is going to give me an area of 3.75 meters squared. Now, to get the area of the whole figure, and we can check to see if we get the same thing as before, we add 3.75 meters squared to 22.5 meters squared to 3.75 meters squared, and we should get 30 meters squared for the area. Now to find the perimeter, again, you just add up all the outsides. So I'm going to erase this so we can see it. So we will add 6 and another 6, so we have 2 6s. And then we have 4 3s. So 6 times 2 is 12, plus 4 times 3 is 12, which gives us a total perimeter of 24 meters. All right, so I hope that you solved that correctly, and now let's look on to the back side. So let's flip over. Now we want to find the area and perimeter of the shaded region. Well, the same thing, we can look at what we know to find out what we want. So the first thing we see is that we have a square and we have some circles. Well, to find the area of just this shaded region, we can find the area of the square and then the area of the circles and subtract them out. So let's find the area of the square. So we'll put S for square and say again it's length times width. So 10 times 10, which gives me 100 inches squared. Now because I don't want these white parts, we can find them and then take them out so that we know we are taking out whatever area that is. So to find the area of a circle, we'll say C for circle. We want to do pi r squared. So r is being the radius. So we'll say pi times the radius of 2 squared, which is pi times 4. So when we do pi times 4, we get 12.56 inches squared. Now you see that we have 4 of them, and they all have the same dimensions, so we can multiply this by 4 and get the total area is going to be 50.24 inches squared. So to find the area of just the shaded region here, we can take the area of my square and subtract out the area of my circles, and we will get 49.76 inches squared for the area. To find the perimeter, it's similar, except for we want the outside. So we are looking at just the outside of the shaded region. So if you notice, looking at the outside, you have all of this. So we'll want the perimeter of the square, 10, 10, 10, and 10. So we have 10 times 4, which gives us 40. And then we want all around here. So if we think about how to find the outside of the circle, we call that the circumference. So we want to know the circumference for these circles. So to find the circumference, we want 2 pi r. So we want 2 times pi, and we're using 3.14 for pi, times the radius of 2. Oh, and you know what up here? Sorry. Okay, so anyway, 2 times pi and 2, we're going to get 4 pi. And again, that's going to give us this 12.56. So it just so happens that for this figure, the circumference and the area are the same. That will not always work for our figures. But in this case, it is, because 2 squared and 2 times 2 is giving you the same dimension. All right, so again, because we have 4 circles, we can multiply this by 4. And we get that the circumference for all the circles is 50.24 to 4 inches. But now if we think about the perimeter, it's this and all of the circles. So my perimeter is actually going to be more. Therefore, we want to add these two together. So if we add 40 and 50.24, we get that the perimeter is 90.24 inches. All right, so now I want you to try to find the area and perimeter of the shaded region for number 4. So I want you to pause this video and try to find the answers. And when you are done, turn the video back on and we will go over it. All right, so you should have paused the video. Now we will look at how to find the area and perimeter of the shaded region. So if we find the area, again, we can find the area of the total. And we see that one side is 8. Just the shaded region is 13, but because both sides have the same distance, we know that all of those are 4. So we want to say 13 plus 4 and 4, which is 8. So that is going to give us a total of 21. So we know that the area of the rectangle is going to be 8 times 21, which is going to give us 168 centimeters squared. Then we see we have 4 little triangles in the corners. So you can say, to find the triangle, we want to do 1/2 base times height, or 1/2 base is 3, height is 4. So 1/2 of 12 is going to give us 6 centimeters squared. Now, because there are 4 of them, we have to multiply 6 by 4 and get a total of 24 centimeters squared. Again, because we don't want the white parts, we want to subtract them out. So 168 minus 24 is going to give us a total of 144 centimeters squared. Now you may have split it into 2 trapezoids and a rectangle. You could have done that as well for your dimensions. All right, so now to find the perimeter, again we want to find all the sides. So if we know that this whole length is 8 and each one of these is 3, we have to say 8 minus 3 and 3, which is 6, which gives us 2 centimeters. And if you notice here, you're missing this side. Well, we just talked about the Pythagorean theorem, and we know that the angles of a rectangle are right angles, so we can use the Pythagorean theorem to find our missing side. So this is the hypotenuse, so we can say 3 squared plus 4 squared equals x squared, or 9 plus 16 is equal to x squared. 25 is equal to x squared. Therefore, x is equal to 5. So we now know that this side is 5. So in order to find the perimeter, we can say 2 lengths of 13 plus 2 lengths of 2 plus 4 lengths of 5. It's a 4 there. And when we add in that all up, we get that the perimeter is 50 centimeters. So, after going through composite figures, I want you to work on the homework. The homework is composite figures and the Pythagorean theorem, and come into class with any questions that you have.